Hey guys, how's it going? I'm back here with another video, and today I decided to bring this video where I'm going to be going over every single thing you need to know about Prisma.io in order for you to be able to use it in any kind of application you might want to use it for. So I'm going to be going over a very simple setup of how to set it up into your project, how to create a simple CRUD with it, and some interesting properties and stuff that you can do with Prisma as well. All the code for this video will be in the description, and I will be using MySQL as the database management system for this video. However, it shouldn't change at all because Prisma makes it in such a way that basically there's no difference between using the different types of databases. It's all very well maintained and very well abstracted, so that the only difference is basically just one line of code. So before we get into the video, if you guys could leave a like and subscribe, I would massively appreciate it. It will help push my videos to more people, and I would be really grateful if you guys could do so. So with that in mind, let's get into the video. Before we get into the video, I want to talk a little bit about today's sponsor, Brilliant.org. So Brilliant has become my favorite place to learn math and computer science interactively. As you know, I'm always trying to dive into new programming topics to bring to this channel, and Brilliant has been an essential tool for me to stay ahead and keep my skills sharp. If you're like me and you love exploring programming languages and understanding the ideas behind data and computer science, Brilliant is literally perfect for you. They have thousands of lessons on foundational and advanced math, AI, data science, neural networks, and more, with new content being added every single month. One course which I repeatedly vouch for and I find incredibly helpful is the Computer Science Fundamentals course. This course is excellent for any programmer looking to strengthen their foundation, or even for beginners wanting to learn the core concepts in computer science. Another amazing course which I've recently started to take is the Introduction to Neural Networks course, which will give you a very solid understanding on how neural networks work and their applications, which is especially useful in today's world with the state of AI and neural networks being used everywhere in our lives. The best part about Brilliant is its interactive learning approach, because you won't just be watching videos, but actually engaging with the content through hands-on exercises, drag and drop coding, and beautiful visualizations. This makes learning not only more effective, but also kind of enjoyable. Now, if you're interested in checking them out, just visit brilliant.org/PedroTech or click in the link in the description. The first 200 of you will get 20% off Brilliant's annual premium subscription. Again, thank you so much, Brilliant, for sponsoring the video. Now let's get into the coding. Okay, everyone. So as you can see, we have over here a very simple application already created. I won't show you guys just creating the initial setup for a NodeJS and Express server, because that's not the point of the video. And it's pretty simple, right? It's something that I'm expecting you guys to already know in order to be learning Prisma. What we have over here is a very simple app, right? It's using Express and Node.js. I only installed 3 packages, as you can see, Express, Node1, and MySQL 2. I forgot to add the script for Node1, but it's very simple. Those 3 packages are just used for their individual purposes. For Node1 is just so that we can, whenever we save a file, we just rerun and run the changes into the new state of the server. Express is because we're going to be using Express as our backend framework, and MySQL 2 is just because we're using MySQL. So our index.js, which is where we actually run our application, is pretty empty, as you can see. All we did was just set up an Express server, use the middleware so that it parses all the JSON that comes through the body of the requests, and then it listens to the requests and runs the server. So that's all we're doing so far. Now we want to be able to connect to a database, in our case would be MySQL, and at the same time make queries and changes to the database by using this ORM that is really popular called Prisma. Now, you might be asking yourself, why would you want to use Prisma instead of other types of ORMs, right? I have tutorials using Sequelize, I have tutorials using Mongoose. If you're talking about MongoDB, I have tutorials using Typeorm. There's like a lot of options out there. However, there's a lot of different benefits and negatives to each of them. I'm going to talk a little bit about why Prisma is really good. I really think that Prisma has a really nice level of abstraction in regards to the queries and stuff you do related to your database. So it's pretty simple. All the methods they have are really easy to understand and really easy to manage. Also, Prisma provide type safety, which is really nice because it is something that especially nowadays, it's really important to have in a backend. In this tutorial, I will be using JavaScript, but it's really simple to set up TypeScript with Prisma, especially because I believe it was built in mind using TypeScript, right? It was built with TypeScript in the back of their heads, right? Also, one of the most important things is the fact that Prisma allows for very easy and really simple migrations. So it will always generate migration files based on the changes that you make into your database. So if you have a team and you're building an application and you all want to have up-to-date information on your database, Prisma makes it very easy for you to do so. And finally, the thing that I think is one of the coolest ones is the fact that it's really simple to set up no matter what kind of database, right? So I mentioned that in only one line of code, you can differentiate between different database management systems. And that just makes it very simple because I can make this tutorial and no matter what database you're using, it will basically be the same thing. So those were the 3 reasons why I think Prisma is really nice. So now that we know that, let's start actually showing how to implement it into an application. Okay, so the first thing we need is to install a couple packages. So we already have 3 packages installed, like I mentioned in the beginning, but we do need to install 2 more, which are going to be related to Prisma. So I'm using Yarn, but if you guys are using NPM, you just run NPM instead of Yarn. So I'm going to say Yarn add Prisma. That's the first Prisma library that we need to install. The second one is the Prisma client. So we're going to put at Prisma/client, just like this. Now it will start installing the packages, and while it's doing that, I want to create a folder over here in our project, and this folder will be used to contain everything related to Prisma inside of our code. So you see I'm using an extension into my VS Code where it even shows that this is stuff related to Prisma, the icon over here. Also, there's an extension called Prisma, this one over here. I would recommend you installing it because it will add syntax highlighting, formatting, and autocompletion to all of your files that end with an extension called .prisma, which we will need to use in this project. So I will recommend you to install it, or else it would just look like a TXT file and it will be kind of hard to work with. So I would recommend installing that extension. Over here in our Prisma file, Prisma folder, I'm going to create a file called schema.prisma, just like this. And this is where we're going to define which database we're using. We're going to define how our database is formatted. And also here's where we're going to write our database tables. So to do that, what I want to do is I want to come over here and first create what is known as the client. To create a client, we need to use what is known as a generator and give it a name as client, just like this. And then we're going to define what provider we're going to be using in this project. Now, the provider is just saying that we want to use the Prisma client and for JavaScript, just like this. So this is directly from the Prisma documentation. This is how they would set up for a project like this. And there's not much to understand from this. It's just how you set up you start setting up your schema. Then we need to define our data source, which would be our database. So I'm going to come over here. I'm going to say data source and DB. And here we need to provide 2 things. First of all, we need to provide what is the database provider we're going to be using, which in this case would be MySQL. So I'm going to say provider is equal to MySQL. And this is where I said it differentiates depending on what type of database you're using. If you're using MongoDB, here's where you would write MongoDB. If you're using Postgres or something like that, here's where you would change to Postgres. And that's basically all the change you need to do, other than obviously running your database in the background, right? I'm talking about code here. It's the only difference you need to do based in code. Then we need to set up the URL that will connect to the database. So here's where you can also argue that it's a little bit different depending on what database you're using, because it will be different no matter what, because here's where you put the connection string to your database that is running in your computer or wherever you're running your database. So for example, I'm running mine inside of my computer. I'm running it inside of my MySQL workbench, right? You don't have to know what this is. This is just, if you use MongoDB, it would be like MongoDB Compass, right? It's just a place so I can see my database connection, see my tables, see everything being displayed in a UI, in a beautiful UI, right? So my connection string is based on my MySQL root connection, this one over here. So if I want to connect, all I have to do is just get this information, but it differentiates depending on if you're using a different database, right? If you worked with MongoDB, you've probably seen those connection strings that you always have to use. So that's the kind of string that you have to put over here. So we don't want to put it directly over here because it is sensitive information. So I actually want to create a .env file. It's where we're going to be storing our database URL, just like this. And what I want to put for this database URL is the connection string to our database. Now for us, for MySQL, it's just going to be first saying that you want to connect to a MySQL database, then do 2 double slashes. Then I'm going to put the username to our connection, which in my case, the username is root. And for a lot of people, it might be root as well, because that's the standard username. So I'm going to put root. Then the password, which in my case is password. It doesn't show over here, but I set it purposely to be called password, just for simplicity reasons. Then we're going to put an @ symbol, and we're going to write the host name, which in my case is localhost, and the port name, which in my case is 3306. Finally, we have to put over here the name of the database we want to connect. Now, this means that you do have to create your database before you do all of this, in order to tell Prisma which database you're going to be working with in this project. So for example, in my MySQL workbench, I'm going to come over here. This is where the connection exists, right? And I'm going to create a schema or create a database. I'm going to call it probably Prisma tutorial, but you guys can call it whatever. Call it something that makes sense to your project, right? If you're building a social media website, call it social media or something like that, right? I'm going to click apply, and I'm going to create my database. Now, you don't have to do it this way because you might not be using MySQL, but as you can see, I have over here a database called Prisma tutorial. So that means that now over here, I'm going to put Prisma tutorial, just like this. Now I'm going to save this, and we're going to come over here to our schema.prisma, and we're going to write env, just like this, and put the name of our variable, which is database URL. So we're just setting the URL to be equal to this value over here. Now we're going to close this data source, and we're going to start creating our first table in Prisma. So to create a table in Prisma, we don't actually have to manually do anything, right? We don't have to come over here and open this up, go to tables and create a table and write the SQL, or if you're using Mongo, write. Actually, Mongo, usually you don't even have to write. It's similar to how you usually do with Mongo, right? You write the code that is going to define the fields and their types for each individual table or collection you have in your database. So if I wanted to create, for example, a user table or a user collection, in Prisma, this is called a model. So I would come over here and say model, give it a name, and this will be the name for your table. So it would be users, and then, or just user actually makes more sense. And then open and close curly braces. Over here, we have to define each individual field and its type. So if I wanted to define an ID, right, because each user should have an ID, I would say ID, put some space, then define the type of ID, which would be an integer. And as you can see, there's already a lot of predetermined types that you can use in Prisma. If you want to look at a list of all the types, you would have to go into the documentation. But with the extension that we installed into our VS Code, it has autocomplete, as you can see. Then I'm going to come over here, and since this is an ID, it's a field that is a little bit different, right? Because I do have to define that this is an ID, so it's an identifier for this specific table. So if you're working with keys and foreign keys or anything like that, you have to identify which of your fields are IDs, right? So in this case, I'm defining this one as the ID. And also, every time you add a new user into the database or into the table, you want it to, by default, auto-increment the ID of that user, because it is a new user and you don't want their IDs to be the same, right? So we're going to put over here at default and say auto increment. So as you can see, there's a lot of cool functions that you can use when defining your models. Then we want to define something else for the user. I'm going to probably put two fields, one called first name, and it's going to be a string, just like this. Then last name, and it's also going to be a string. Then I'm probably going to put age, and it's going to be an int, just like this. And I think for now that should be fine. Like, I think I don't want to overcomplicate each model, but for now, let's just keep it like that. I also want to add two different fields that are important to know and have when you're working with database and tables, which are the created at and updated at field. They're often overlooked. But basically what they do is allows you to know when each user or when each entry in a table was inserted, so you will know when a user account was created, and know when it was last updated. So I'm going to put over here the created at field, and it will be a date time type. So it will be a date, right? And we'll include the exact time of when this thing was created. And the cool thing is we don't even have to do anything, because a Prisma will automatically know when you're creating this thing and will automatically put the correct time. If we come over here and say that by default, this value will be equal to right now, just like this, right? So it's very intuitive, the syntax. The updated at would actually be just as simple, just a little bit different. Will also be a datetime, but there's also a specific value where we can just say at, updated at, and it will always fill in the correct information. So now we created this model called user. Doesn't mean that we will see automatically here in our list of tables. Well, no, because we haven't told Prisma to generate that, like transform this code into actual SQL or whatever kind of database you're using, an actual code that would generate that thing into the server, right? So in order to actually do this, we have to run some commands in our terminal. So the first command I want to run is yarn prisma generate. Now, if you're using npm, you should run npx prisma generate. So I'm using yarn, I'll just run yarn prisma generate. It will generate the thing for us. But this won't do anything. As you can see over here, if I refresh all, technically it hasn't done anything yet. The next thing will actually start generating some stuff into our table. I'm gonna run yarn prisma migrate dev, then -- name init, and -- create only. So this command will basically just generate a version of Prisma, of a Prisma table inside of our actual database, and this will be used to keep track of a lot of stuff related to Prisma. And it is essential that we have this in order to use everything that Prisma can provide for us. So when I run this, it will actually generate a table in our tables thing over here. It will be called Prisma migrations. This will include all of our migrations. Now, the last thing we need to do is migrate and deploy our actual model, right? The user model. So to do that, I'm just gonna run yarn prisma migrate deploy. So whenever you make a change like a model, you should run the deploy. And this is what is actually going to successfully apply the models that you create. So if you want to check, I'll just come over here and refresh our tables thing, and you should see the user table now over here. In MySQL, I can see each column individually, and you can see they are exactly the columns that we created in our thing over here. Thing is, so now that we have set up our table and everything seems to be working, I think it's important that we start writing the code for like inserting data, deleting data, updating data, and reading data on our database. So what I'm going to do is I'm going to come over here to our index.js, and I'm going to create a couple what is known as endpoints inside of our backend. Our server will include at least one for each type of operation that we're going to be doing. So to create an endpoint or to create a route over here, I'm just going to say app.get, and I'm going to create our first one, which is going to be a GET request, which we're going to be using for fetching data from our database. So in this GET request, we're going to just retrieve every single entry in our database. I'm going to do that by actually starting up an instance of our Prisma client. And to get the Prisma client, we have to come over here and import from the Prisma, let me see, require at Prisma /client, and we're going to import the Prisma client class. And down here, actually up here, I'll do it up here, and I'll just say const Prisma is equal to new Prisma client, just like this. Now with this, we can do every single operation we want to do to our database. So for example, if I wanted to come over here to our GET request and make it such that when you request to this URL over here, you would retrieve back all of the current users in the database, all you have to do is create a variable called all users, something like this, and set it equal to Prisma dot the name of the model that you want to access, which in our case is user. And as you can see, there's already auto complete because we created this model already. And then we press dot and just get all of them by saying find many. just like this. Now this should return a list of all the users, and if you want to return back, we can just say something like res.json and return back all users. Now one important thing is the fact that this over here, it's since it is a database request, we have to use this will return a promise, so we can use either a .then.catch method or we can use an async await notation, right? So I'm going to make this function asynchronous, and I'm going to tell the request to await for this request to be done so that we get the actual list of users. Now, if we were to test this out, it wouldn't actually work because we have no users in the table yet. It would work, but it would just return an empty list, right? So this is not what we want. We want to be able to first add some users to that database using Prisma to then be able to fetch all of the users in the table. So let's do the create part of a CRUD, which is to create a user. So for that, I'm going to have a post request just like this. And I'm expecting that when you create this, you're going to get the data back from the body. So we're going to have some sort of object like this rec.body over here should probably be an object containing something like the name, the first name. So you should probably have a first name, a last name, and the age, right? Those were the three fields I believe we made on our schema, right? The created at, updated at, and ID, they are auto-generated. So they really don't need to be sent from the body in the request. So the three pieces of information we really need is this three over here. So to do that, we're assuming that it will be sent through the body. So if you want to create a new user, all we do is we just create a variable called new user over here, say prisma.user, and use the function create. Now the function create is pretty simple. All you have to pass in is an object that will contain a data object. And the data object should be the data that you want to use to create the user. Now in our case, we have that data being passed through the rec.body. So we just say rec.body over here and assume that it will work. And just as a return, we're just going to return the new user that has been created. And we can start testing that out. I'm going to open up Insomnia, which is the API tester that I'm going to use, but you can use Postman or you can just build a front end for this as well if you're interested in doing that. But we're going to be using Insomnia in this video. So as you can see, we have over here Insomnia opened inside of my computer, but I actually have to run this code. So I'm going to come over here and run yarn start. And it should start running our server on the port 3001. I'm going to just as an initial to test to see if our server is actually working, I'm just going to do a GET request, but as you might expect, it should return an empty array. But the good thing is, it seems that because there was no errors, right, and the request was successful, it means that our connection to our database is working. Now, the only way to truly test this is by creating a new request over here, which is going to be used for the post, right? So for creating a user. So I'm going to come over here. I'm going to say post. And I'm going to set to pass in some JSON as the body. So the JSON, all we need is a variable or field called first name. And it's going to be, let's try to create a Pedro. And then last name. So last name. And we'll try to create my last name, which is Machado. And my age. So try to guess my age. I don't know if you guys know my age, but I'm 21. And I'm going to be turning 22 in a couple months. I'm going to press send, and as you can see, we did get back some information, which means that it probably is working, right? We got back not only the first name, last name, and age, but the created at, updated at, and the ID got auto-generated because of Prisma. Now, to test this out, we can directly come to our MySQL workbench and select all users, and we should now see a new user over here, which we do. Not only that, but if we now do a GET request, it should return that user as well. So it seems to be working. I'm just going to create another user over here just as an example. Let's say this person is 22, and let's create as well, I don't know, someone else. And one more person, I'll create a girl. But yeah. Okay, I'm going to create this people. Now we should see that all the users are appearing inside of our thing. Now let's go into updating a user. So how exactly would we do that? Well, to do that, we're going to just copy this over here. And we're going to put a put request because that will be representing an update. And over here, we're probably just going to allow them to update their age. I know it doesn't really make sense. You don't change your age, but it's for simplicity reasons. We'll keep it like that. So the way we're going to do this is we need to be able to recognize which user we want to update based on the request, right? So I'm going to get the ID of the user which we want to update as a param to this put request. So I'm going to say const ID is equal to rec.params.id. This is pretty simple Node.js Express stuff. All we're doing is just getting the ID from the request so that we know which user we want to update, or else we would be updating for every user, which doesn't really make sense. Then we also need the information that is going to be the new value for the field that we want to update. We're going to pass that through the body. And I'm going to get that like this. I'm going to put new age over here is equal to rec.body.age. So I'm expecting them to pass a body with age value, and that will be equal to the new age that we're going to update the user to be with, right? So for updating, it's actually pretty simple. All we do is we just use the update method instead of the create. And we need to pass in two things, actually. We need to pass in first a where field, which will just identify, like it will be used to identify which user we want to update, and a data field. So the data we're already passing, and it actually should be a little bit different. It should be the new value that you want to pass in. So age should be equal to new age, right? We want to update age to be equal to new age, but the where should be where the ID is equal to the ID that we have over here. Now we need to parse this integer. So because it will come as a string. So we'll say parse int over here and save this like this. Now I'm going to return updated user, and we can test this out to see if it is working. So let's come over here to our Insomnia, create another request. It will be same as before, but it will be a put request this time. So put and a JSON. But the thing is, we only need age, right? So the ID should be passed as params. So I'm going to be trying to update, let's see all the users. Let's update Paulo's, this guy over here. Let's update their age. So they're 22 at the current time. Let's pass in a value for age of 39. I don't know. And the ID for Paulo is 2. So I'm going to pass in the ID over here as 2. Now I'm going to send this, and it should return back. Oh, I forgot to put the quotation marks around the age. So this is JSON, so it should have quotation marks. I'm going to try it again, and you can see it showed the user Paulo, but with a different age. Now, if you come over here and try it again, we should see that the age for Paulo updated, and in our database, it updated as well. It also just showed all the different users, but yeah, age for Paulo is 39. Now, finally, for now, we're going to do delete, but we're also going to do a couple other things that are really cool that you can do with Prisma as well. But to finalize the CRUD part of this tutorial, let's do delete. It's going to be simple, just like the other ones. We're just going to copy this up over here, put it over here, and change the request type to delete. Now, delete is pretty simple because it actually is, all it requires is just the ID of the user that you want to delete. So we're just going to copy this thing over here. Actually, I'll keep this. I'll just delete this. And I'll change this to prisma.user.delete. And all I need is to know which user I'm going to delete. I don't need to pass in any data. So I'm going to delete this. And we're just going to keep the where clause over here. Now, this where is going to be where the ID is equal to the ID. So all we're doing is, in this request, we're going to pass in the ID of the user we want to delete and delete that user, right? I'm going to change this to deleted user and return back deleted user. And that's the request pretty much done. We're going to come over here and again, create over here another request. We're getting fast with this now. Delete over here, change this to, we don't even need to pass in any body. We didn't use a body in this case. Let's delete Paulo. Yeah, he deserves to be deleted. Let's delete him. I'm going to put over here the ID 2 and send. You should see that the user that got deleted was Paulo. But did he really get deleted? The only way to check is to make a GET request again and see if Paulo is there, which he is not. And similar thing in our Workbench database. He is not there, meaning that we deleted that user successfully. So now what I want to introduce to you guys is the idea of relations, right? So if you guys are familiar with relational databases and relations in general, that's a really important concept. It basically refers to, imagine if we have a model, right? I'm going to open up here our schema. Imagine we have this user model, and inside of the user, it has a field which refers to a different model, right? So there is a relation between both models, and that relation must be identified and correctly managed by the way you set up your database and your tables. And this is not that complicated, honestly, but it's seen as complicated by a lot of people. And I think there's easier ways to understand it. And I think that with Prisma, it becomes really simple to do something like that. So in order to introduce that topic, I'm going to introduce the idea with a very simple example. Imagine that this website or whatever we're creating over here is supposed to be handling or demonstrating data related to users and the houses that they own, right? So there's users in the website, and there's houses that they might own or houses that they might have built, right? So imagine this example. You're just a user in this website, and you can either have built a house or owned the house or done both, right? We don't know. But that's the relation between a new model we're going to create called house and the model that we created before called user. So in order to do that, we're going to come over here and we're going to create a model called house, just like this. Now house will have an ID similar to what we did, which is an int, but actually this time I want to make it a little bit different. If you recall, we auto-incremented the ID, meaning that each user has an ID 1, 2, 3, 4, so it keeps incrementing, right? So you can almost guarantee that if you know your ID, you can guarantee that there is a user with the ID previous, like the one before yours, which is very dangerous because if you know a user's ID, then what's the point of the ID, right? It's supposed to be an identifier, and you shouldn't be knowing or guessing IDs from other people. So there's a way to do this. Instead of making this an int, we can make this a string and define it still as an ID. But by default, instead of using the auto increment function, Prisma has a UUID function, which if you don't know, UUID is just it's a library, and it will provide you with like very randomized IDs that are combination of strings and numbers. So it's very random, and it makes it a lot more secure this way. So we're also going to do that with our user over here. I did that as an example in the beginning, but now we're changing it to make it more secure. Now, I also want to have the created at and updated at. We'll keep that at the bottom. So I'll just save it like this. But in between, I want to have the address of the house. So I'll put address like this, and it will be a string. Pretty simple. And also, the address should be unique, right? Because you shouldn't have multiple houses in the same address. So if you want to make this unique, you can just put the @ symbol and then unique. So it won't allow houses to be created inside of this database with the same address. So that's another property that is kind of cool, the unique property. Now, if I want to put over here a property, let's see. Now, I know this example might seem a little bit far-fetched, but it was the best that I could come up with. Imagine that for some reason you want to keep track of the Wi-Fi password for the house somehow, right? So if you were to put over here Wi-Fi password as a field, and it would be a string, obviously. Not every house technically have to have Wi-Fi. So what I really wanted to show you guys with this example is the fact that if some houses need this field called Wi-Fi password and some houses don't have Wi-Fi, so therefore they don't have a Wi-Fi password, you can make this field optional by putting a question mark after the data type, just like this. Now, that's just an example. Let's continue moving forward. The actual important thing that I wanted to show you guys related to relation here is the fact that a house has to be owned by a user, right? In this case. So I'm going to add a field over here called owned or owner, just like this, owner. And owner is a user. So I can directly reference the user model, just like this. Now, as you can see, there is a red line over here. It is because it requires, if you're going to reference and make a relation like this, it requires a couple more stuff. The first thing is it requires an actual field that you're going to refer to with this user or with this relation. So what I mean by that is if we have a user that is an owner, we need an owner ID or a user ID. But in our case over here, it's called owner ID. So we're going to add a field called owner ID that is going to refer to the ID of the user who is the owner. So that's pretty much passed, as you can see over here, but we still have a red line because we still have to define, first of all, which field is this going to be related to. So to do that, all we do is we put an @ symbol and then relation, just like this. And we pass in first the fields that are going to be, that we're going to get from that user. In our case, it will be the ID. So we just pass in the owner ID over here. And then we also need the references. So references is like, if you're familiar with relational databases, like I said, it's kind of like this will be a foreign key to the user's model. So we're going to put over here the ID for the user's model. Now we still have an error, and we can fix this error by running Prisma format over here. I'm going to open up the terminal and I'm just going to run Prisma format, just like this. Oh, I need to, it's yarn Prisma format. And then press enter. And you can see that it made a lot of changes into our code, right? The main ones is that, as you can see, we don't have a red line anymore. The reason for that is because when we are having a relation like this, we do need to have a field on the opposite model, which in this case is the user, referring to this specific model, which is house. So what we have here now is we see that a user can have an array of houses, right? Because it can be owned by, it can own a house. So that's why when we're adding the fields on the house field, it makes sure that we do it correctly by adding this field over here as well. Now, another field I want to add is the field for the built by, or the builder, the person who built the house. Again, might be a little bit far-fetched, but try to keep up with me. This is just an example. It's just because I wanted to have another user being referenced in the house. So I'm going to come over here and say built by, and then it will have to be a user. So a user had to build this thing. So I'm going to have to add the built by ID as well over here. And it's going to be a string as well. Now you can see that there's some errors over here, and it's because we have to do the exact same thing we did with this, but over here, as you can see. But it still gives us an error message. The reason for that is because we can't have two fields referencing the same table without distinguishing themselves from each other. So what I mean by that is we need to add a label to both fields to actually have a distinction between them in this model over here. So what we'll do is we'll just create a label that you can do by adding it as the first argument in this function call over here. And on this one, we're going to say house owner. And this over here, we're going to add the house builder. Something like this, right? And it's still giving us some errors because now when we have over here our house, I'm actually going to change this name to house owned. So a user can have a house that they own, and it will be a house, but they can also have a house that they built. So I'm going to put over here house built. And to distinguish both of them, I'm going to say that they are part of a relation. Now I'm going to use the label that we have over here as the relation to identify the correct relation. So we have house owner as this field over here. And on this one, we have house builder. So I'm just going to put over here house builder and then save it. Now it's still giving us an error, but the reason for it is we know it's because I just copied and pasted this from this, but it didn't change the fact that the field for this should be the built by ID field and not the owner ID. And you can see that now it doesn't show any error messages or anything. We can still format it by running yarn Prisma format and it will look all pretty, but it means that we correctly did this, right? Now, how will this look? Well, first of all, I'm going to come over here and I'm going to run the commands for migrating the database like we did before. So I'm going to come over here and say yarn Prisma migrate deploy, right? Press enter. It says no pending migration to apply. We're going to save this. And when I'm going to come over here into our database, if I fetch the data, it still looks the same, right? Pretty much looks the exact same. Now what we have to do is just use the commands that we used before to make the direct changes to our database. So I'm gonna run yarn Prisma migrate dev -- name init -- create only. Then I'm gonna press enter, and it should probably ask you if you wanna make the changes, and you can just press Y as the enter. But as you can see, it worked here. Then I'm gonna run yarn Prisma migrate deploy, press enter. It's gonna make all the changes. And now that we have these changes done, we're gonna come over here to our MySQL workbench. We're gonna refresh all the table, and you should see that now we have a new table over here, which is the house table. And the house table not only has all these columns over here, but it also has a foreign key, two of them in fact, which are the house built by ID key and the house owner ID key. So those are the two ones that we created, and it is being reflected over here inside of our database. Now, in between the takes, I actually created a bunch of users because since we changed the way that the ID is set, right? Now we have UUID as the ID for the user instead of just auto increment. I had to regenerate them, so I just created them again. And you can see that each user now has an actual random ID, right? So now what we want to do is we want to add the functionalities to implement and set, for example, an owner for a house, or even to create a house. So the first thing we want to do is we want to be able to create a house. So I'm going to come over here, and we're going to create a new request, and it's going to be a post request similar to this one. I'm going to put it down here, and we're going to, since it is a post request for the house, we can use this over here and change it to /house. So we differentiate this from the one for the user. If we wanted to, we would probably want to put user over here, but since we already created and I already have all those requests over here done, I don't want to waste time on that. We'll just do those for the house. So in this request over here, we want to create a new house. So it would be similar to what we've been doing, right? We would say new house, and then await prisma.house.create, and then over here, we would have to pass in the data. Now, for a house, we need an ID, right? But that ID is auto-generated. We need an address, which we have to pass. We need a Wi-Fi password in case we want to pass that in. And we need an owner or an owner ID, and a built by or a built by ID. Now, we have a couple fields over here, and this is where you are able to differentiate the fields for owner and owner ID and the fields for built by and built by ID. The reason why we had to include both of them is not because when you create a house, you must pass in a user as the owner. You actually don't pass in anything. You pass in for the owner ID. That's all you have to pass in. Same thing for the built by ID. You pass both of them in, and that's what's going to be stored in the database. But when you query the house, it will get that ID and automatically use that ID to query the user, and thus fulfill the owner field over here. So, and the built by field over here. So if we were to create this, we would probably want it to look something like this. Let's assume that in the data over here, we're going to pass in a couple stuff. We're going to pass in first the address, the Wi-Fi password, in case we want to pass that in, the owner ID, and the built by ID. So we're assuming we're passing that in. So this over here should technically work just like this. But the way to truly test this is by coming to our Insomnia and creating a new HTTP request over here. It's going to be a post request, copying all of this over here, and setting up the JSON format. Now, like I said, we want to first pass an address. The address, I'm going to put here a random address, random street, and I'll put a number over here, 6543, random street, and then a postal code. I'm just putting postal codes like how they look like in Canada. So this is the address. Then I'm going to come over here and I'm going to add the owner ID. So owner ID. Now for the owner ID, let me take a look how we structure it. Yeah, it's ID with a lowercase d. For that, we do need to get one of the owners. Let's say that the owner for this house is Angela Machado. I'm going to copy this over here and put it over here. and then save it. And then the built by ID will probably built by ID. Let's make it be, I don't know. I'll make it, I'll put myself as the builder. So I'll just copy this and put it over here. Now, when you pass this in, you see that there was an error. And let's check to see what was the error, because I actually have no idea. It says that it was missing some stuff. Oh, I know what the mistake was. And I like to include mistakes in my videos. You guys know this if you guys watch me, because I don't want to pretend like I do everything flawlessly. I think it's interesting to see the mistakes that the person making the tutorial goes through as well. So it was a dumb mistake. I forgot to change the URL to be the house one. So it was trying to create a user and passing in this stuff, since when the user don't take in this stuff, right? This is for the house. So if I change this to house and I actually have to restart my server, right? I'm gonna restart this by just saving my index.js file, and it will run again. Now let's try to run this again. And we should see that it was created, right? Which is beautiful. So the way we test this is we come to our user table and we select it. Oh, not user. We should select the house table. We should see that now we have a house over here. It doesn't have anything for the Wi-Fi password because, again, we didn't add anything for the Wi-Fi password. I am indeed going to create a new one just to test out the Wi-Fi password functionality. So Wi-Fi password over here. Let's put the password to be password. And let's change this to 8912 random street, and let's make it such that it's like this. And the owner will be the same person, but the other person will be Colin. So I'm gonna put Colin over here, and I'm gonna paste this. You should see that now we have created another house, but on this one, the field for Wi-Fi password is not no, it is password. So it seems to be working pretty well, but how do we see the relation actually happening? The way we do this is by actually coming over here and creating another GET request. I'm gonna create two of them just to show you guys two different functionalities that you can also have in Prisma. The first one is just gonna be a simple GET for the house where we're gonna find all the houses. But if we wanna specify that we wanna include the fields for built by an owner, we have to say that, because if we don't, it's just going to return every other field, but not actually include the actual user that refers to this owner ID and the user that refers to this built by ID. So if we want to get back a list of all the houses, but for each house that has an owner and a built by person, they would include the information for that user. You can just come over here and add a specification to include those two fields. Include owner. It's called house owned. No, oh, I get what's happening. So I should change this to house, not user. So it should be owner, as you can see. And we say that we want to include the owner, and we also want to get the built by. And we say that we want to include the built by. So I'm going to change this to all houses, paste it over here. We can test this one out. For simplicity reasons, let's just reuse the same request. I don't want to keep creating requests. It just takes time. We're going to use a get to the house, and we're going to run send, and we should see all the houses. But not only that, but they have the field for owner, which includes the information for that specific owner, right? So it includes all the information for that. So we established a relation and we made a query that fulfills that need to get the information for that owner. And the same thing goes for the built by. For those, there's only two houses, and it seems to be working. But if you want to check to see what happens if we put false, look at this. If I put false for this, we should get the information for the owner, but not for the built by. And this is exactly what happens. We don't even get a built by field if we don't set that up. Now, I want to just show you guys how we can change this to get a specific house. So it's kind of like finding by ID. I would put over here an ID field in this params if I wanted to do so. And to do that, it's actually pretty simple. You would pretty much, so you would get the ID, const ID is equal to rec.params.id, right? We're getting it from the params over here. And all you would have to do is just, instead of saying find many, you would say find unique. And unique is just, you can pass here which condition you want to be the unique condition. This would work on all the fields that are unique. So over here we have a couple fields, right? In the house, we have two fields technically. We have the address and the ID. If we wanted to find by ID, we would say that we want to find the house with the ID equal to the ID, which would simplify to just this in JavaScript. And this would work. If we came over here and I copied out, let's imagine I want to get this house. I'll just copy this ID, pass it over here, and I send it. You'll see that now I'm getting that specific house. If I want to do it by address, I can change this to address, like this. Actually, I will pass it through the body because I feel like an address is better to be passed through the body. So I'm going to say body.address and get the address here. And where address is equal to address. We can specify that as well. And then I'll just get the address for this house. And just instead of putting it over here, I'm going to delete this and pass in a body for this request. So I'm going to say address, like address is equal to this. I'm going to send. You'll see that we do get this specific house. If we pass in the wrong address, we don't get anything because we're not satisfying the needs for this request. So this is pretty much it for the relation between different models. Now, I wanted to speedrun a couple cool things that you can do just because they're minor things that you can just learn really quickly. And I think it will add value to the video, but not a lot of time to the video because I don't want to waste you guys' time. So a couple cool things is the first one, you can actually create many, like add many things at once to a table. So if you change this to create many, just like this, instead of just the create, and you pass in, instead of just an object for the data, you pass in an array with objects, which I'm assuming I'm going to get from the rect.body here. I changed the route to be a different route. And if I did that and came over here and made the request, you see through the body, I'm passing an array of houses instead of just one house. This would work. It returns back the count of how many houses you created. But if we check over here in our database, now we should have a lot of houses, right? We have all of the houses we just created. I didn't change much between them. I just changed the address because it has to be unique. Also, a cool thing to see is that if I try to create the same house twice, right? Maybe even by different like information, I can even remove this over here. But the fact that the address is the same, it shouldn't work because it is unique, right? And we shouldn't allow houses to have different or the same addresses, right? So this is a cool thing you can do. Okay, so the last thing I want to show you guys is how to filter and sort queries. So this might be a little bit complicated, but just try to stick with me. It's actually pretty simple if you analyze all the properties and stuff you can do with Prisma. So basically what we want over here is we created this route called house/with filters, and we can specify different things that we want to have, like requirements that we want to have in our queries. So for example, if I want to find a bunch of houses, right? I'm trying to query a bunch of houses, but I want to specify that in those houses that I query, I don't want the Wi-Fi password to be null. So I can just do like this. I can say Wi-Fi password, and then a property of the Wi-Fi password field will be that it is not null. So that's pretty much good, right? If we do that, it will give us all the houses without a Wi-Fi password, with a Wi-Fi password. Now, what if I want to specify that, not only that, but I want the age of the owner field to be greater than or equal to 22. So we have a bunch of users, right? If you recall, we have a bunch of users, and I am the user Pedro Machado is the only user which is under 22. And if we go over here to the houses table, we'll see that I do have a house. I don't know if you can see because we don't know the ID, but I did make sure that I created a house with my ID. So we do have a house. So when I query this, we shouldn't see a house with which I am a owner. So that should be guaranteed by this filter over here. Now, what about ordering? Well, this is all for filtering, but what if I want to order my results based on alphabetical order, descending from the user's first name? So technically we have here a bunch of users, right? The user with the first name if it was descending in alphabetic order, should be Angela because it starts with an A, and A is the first letter in the alphabet. So I made sure to create some data so that this will be distinguished when we query this. Now, I also want to include the owner and the built by information because that's important. And this over here should return a query that follows all of the implications that we put over here. So let's try that out. I already created over here the request. It is just a simple GET request with this. If I click send, you should see a list of houses, right? But not only that, we should see that it only shows houses where there is a Wi-Fi password. So you can see there's all of them. There's no one of them without a Wi-Fi password. But also, all of the houses that are showing are by people older than 21. Or older than or equal to 22, right? So there's no houses where the owner, if you see the owner field, there's no houses by me because I'm the only one under 22. And not only that, but the houses owned by Angela shows first. When the ones owned by Colin, which is the only one that isn't owned by Angela in this case, is shown last. So it is currently ordering, it is currently filtering, and this is a pretty cool thing because honestly, adding all of this stuff when you're doing like SQL queries and such are kind of annoying. I personally work a lot with SQL, so I know for a fact it is annoying. So doing all of this in JavaScript is pretty cool, and Prisma provides you with that opportunity. So this was basically it. I really hope you guys enjoyed it. If you enjoyed it, please leave a like down below and comment what you want to see next. Subscribe because I'm posting every week, and I'm almost done with my school, like almost for real, like completely done with university. And after that, it'll be a breeze to post for you guys. I'll have a lot more time to do so. I'm gonna be working, but I still think I'll have more time. So I'll be posting a lot more videos, providing a lot more content for you guys. So yeah, that's basically it. Really hope you guys enjoyed it, and I see you guys next time.